Hi friends, welcome to the cardiac exercise part 2, and I would suggest you to watch cardiac exercise part 1 before watching this. Now as we discussed in cardiac exercise part 1 that some of the basic points that we discussed and which are very important to note here, these are first of all the polarities of the leads. Polarity of leads, that is to say, what do we mean by it and how do we put this perspective on ECG. Now as we discussed that when we say that the depolarization wave is traveling towards a positive electrode, the ECG records it as an upward deflection, and when it moves away from the positive electrode, it records as a negative deflection. Now friends, here we need to pay attention that there are one midpoint between them, that when the depolarization wave is perpendicular to the lead, and that is equiphasic potential. Now to understand this, first of all, basically we need to have a rigorous concepts about vectors, and vectors are really essential, and I would suggest you to read a introductory lecture on vectors so that you may understand this better. Now to understand the polarity of leads, we need to know the vectors and the depolarization wave traveling concepts. Now just to put that in your mind, for example, we have positive and we have negative electrodes. Now it's just that the what we say that electrical axis, for example, this part of lead is negative and this is a positive. Now when we see any view of the heart, like for example it is this, and the wave is traveling towards here. Now the wave is traveling towards here, the wave of depolarization. Now we note this as in ECG we have this condition, this is traveling towards positive, and this we will record like this, and vice versa. If it is traveling here, we would record as a negative deflection. It is positive deflection and it is a negative deflection. Now it's very primitive concept. It is expected from you that you know this prior to understanding the cardiac axis. Now friends, I would like to tell you about what is an equiphasic complex. Now when I was reading ECG and I was put at this point that, for example, this A wave, okay, let me make it larger for you. This is isoelectric line. The wave of depolarization, for example, this is perpendicular to the lead. For example, we are taking any lead X, and this is viewing from heart from this point of view, and the wave of depolarization is traveling towards here. Then we will attain this waveform. Now to just to mug it up that it is the correlation, but it won't work in good interpretation. We need to understand this, and this concept is very unexplained, and I think nobody has explained till now what's the real meaning when we say that. Obviously we are saying that it is perpendicular, but how can you put this situation in your mind to get this, that it was interpreted like this? Now just to explain you that, first of all, as I said, you have to got a real knowledge of vectorial analysis before interpreting the ECG, as ECG is very close to the vectorial physics. Now just okay, now going back to the basics, when we were reading about the For example, the axis of any vector we have given like a vector x. Now for example, this is one axis and this is other axis. Now we want to take its shadow at one angle, and this is theta and this is theta 1. What potential would be reflected here and what potential of this shadow would be reflected here? So we can take that it is theta 1 voltage and this is theta 2 voltage. Okay, now we know that the shadow of this would be reflected here, and by the physics knowledge I can just give you one point that as theta equals to 90, excuse me, at theta equals to 90 degree, just listen it, at theta is to 90 degree, the component of vector that we are dealing with, for example the vector which we will be dealing with, it will be QRS axis vector. Now here it is any x vector. Now the component of the vector at 90 degree, it would be 0. Now the net reflection on that part, for example here we have 90 degree, now here we get 0 component of it. It means that we will get this vector shadow between theta equals to this 0 degree, for example angle from this to the 90 degree vector. This part we will get some shadows of this vectors. Now I hope that please retain this in your mind forever to have the basic concept of cardiac axis. Now this I am emphasizing you because when we will like to derive the axis from the heart, from the waves from the heart, we need to have the clear concept of this, and I assure you that nobody has given this type of explanation in any video or in any book. It is not written, and it is the very basic explanation of this part, and I hope that you have achieved that successfully. Now the second part of this, that how we can prove that, means how we can correlate that 90 equals to theta equals to 90 we have vector 0 with this waveform, the waveform which I wanted to explain you. For example, here we have the lead view. We have the lead view here, and we have the wave of depolarization traveling from wave of depolarization. Now consider this, up to this part we have this wave, and up to this part we have this wave. Now we can obviously in vectors what we do, that it is positive and it is negative. If we add it, what we get net 0 potential of that vector. Exactly what we told, that the shadow of the vector which was formed here, and at 90 degree the shadow would be 0. Exactly we are getting this. Now I hope that you have achieved this concept very clearly. Now moving to the point, as I have explained you the more basics part of the cardiac axis. Now just move towards a more biological part. First, as I have explained you the more physical biophysics part of the cardiac axis. Now